Okay, welcome back. Ben Gartland here again. So this is part 2 of the how to configure and use the Analyser Trace. In the previous video we had a quick look at how to configure the Analyser Trace, but not actually how to read any traces. So what we're going to do here, we're going to trace some Telnet traffic and try and work out what the issue is. So first of all, let's show you how the network is configured. I've got this laptop that's being used for the recording with an Ethernet connection with the address 192.168.0.38. There's a WR41v2 with its Ethernet configured as 192.168.0.39, and it's also got a mobile connection. That's the cellular interface, and that's a private dynamic address. Then we've got the traffic going to go out over the internet, and we're using a WR44v2 on an ADSL line, and we're just going to use the Telnet service as a server to connect to. And we're going to use this address here that is configured on the WR44v2, and that's a public dynamic address. On the 44, port 23 is blocked, so we're going to have a look at what we see in the trace when we see a blocked port, and we've also got port 8023, which is open. So the transport routers will respond on the original well-known port number of 0 to 1024. So in this case 23 is Telnet, but they will also respond on 8000 plus the original number, so it will also respond on 8023 for Telnet as well. So then, let's pop down into Putty first of all, and we'll try and open a connection to the router on port 23 and see what happens. Look at that. Okay, so this could be a fairly normal type of troubleshooting issue that as a network admin you'll probably come across. Someone on your network might be saying, hey, we've been told we can access this server, but for some reason it's not working. Can you help? And what you need to do then is basically work out if the traffic's getting off your network and if you're getting any response from the server. So we can use the Digi TransPort's Analyser Trace function to help with this. So we're going to Management Analyzer and then click on Settings. Now the default settings you see here, the maximum packet size to capture is 128. We're only using Telnet, so the packet size isn't going to be particularly big, but if you do want to capture the full packet, the payload, while you're doing any tracing, just put that up to 1500, and the log size is 180 is the maximum. So good habit to get into, just increase those. Then the sources that we're interested in, we're using IP sources because we want to trace at layer 3. So we're going to enable tracing on Ethernet 0 and PVP1. Right, so let's just hit apply and see what we see in the trace straight away. So we'll scroll down, open the trace, and whoa, look at all this. So if we scroll down, we'll see loads of stuff in the trace already. And what this is data between the laptop and the router. So this is just web traffic basically. While we're doing this session, the management of the router and opening all the pages is causing all this traffic. There's going to be other stuff in there. There might be a bit of net BIOS as well, port 137, that kind of thing. So what we'll do is we'll filter out what we think is likely to going to be there. So let's say 80 and 137. Seeing as it's a Windows PC, it's likely to be port 137 seen in the trace. To filter out, you simply put the details in that you want to filter on. So for the TCP UDP ports, we're filtering out 80 and 137. If you wanted to filter in, you put a tilde in front, and that makes that data appear in the trace. I'd probably recommend you start by filtering out, because you will see more information, which we'll come to shortly. So we'll clear that and refresh, and do we see anything else? No, we don't. Okay, so the trace is ready to go. So what we can do now is we can run a new Putty session. So that's trying, and we can see press enter a couple of times, going nowhere. Let's refresh this and see what we see. So the first packet that we see is a Telnet packet. We can see here it says Telnet. Now if you notice here, before we go into any of the packet detail, this top packet is indented and this lower packet is hard up against the border on the left. And there's good reason for that. Anything that's indented means it is inbound to the router. So whether it's on an Ethernet interface or a PPP interface, it's inbound to the router. Anything that's left against the edge is outbound from the router. So let's have a look at this packet in a bit more detail. We can see it is an IP packet, it's inbound, and it even says here it's from remote to local, and it's using interface Ethernet 0. We can see that the protocol is TCP, and if we scroll down just a little bit more, we can see that the source IP address is that of the Windows laptop, and we can see the destination is the ADSL connected router. The source port, take note here, is 52254, and the destination port is 23, which we all know is Telnet. And this packet is a SYN, which is the first part of a three-way handshake. We come down to the next packet, and it says again it's an IP packet. It's going from local this time to remote, so this is the outbound packet on PPP1. We'll come down a bit more, we'll see it's a TCP packet. But look at here, the source address has been changed to the IP address of the PPP interface of the cellular connection. That's on the WR41. The destination address has remained the same, so this has had NAT applied now to change the source address. Note the source port is still the same, 52254, and the destination port is still 1023, so no change there. And this is a SYN. So we've seen the packet arrive at the router and get sent onwards. And here's what's happening. So packet's indented, so it's inbound. Here's the packet, it's indented, so it's inbound. And what we see is it's from remote to local. Interface is PPP1, and it's an ICMP packet. Notice the source is that of the ADSL router, and the destination is the IP address on the WR41 cellular connection. Interestingly, we get an ICMP message, destination unreachable, and it tells us exactly why it's failed. It says port unreachable. Now this means that the port is closed and the router has returned an error code, so we know exactly why the connection failed. Now you won't always see this on all services. A lot of people do disable ICMP return codes, so it just looks like there is nothing there. That's just basic security. People do it, but don't expect to be able to see ICMP error messages on everything that you see. If we come down a bit further, you'll see another SYN packet as the Windows PC tries again. You can also have a look at the timestamps. Here's one timestamp, 07:53:47. Note this, the time isn't actually correct. But here is the previous timestamp, so it's a second earlier. So we can see that it is actually a separate packet going out. In fact, there's the outbound packet, 07:53:44. Okay, so we know that that's blocked, and then you can go to the network admin of the other server and say, look, we've been trying to connect to your server. We can see the packets going out, but you're sending an ICMP port unreachable. What's going on? And they'll probably turn around and say, well, you're trying to connect to port 23 and that's blocked. We use H23 instead. But what would happen if instead of filtering out, you filtered in? So let's just change it. Let's say we think we know what we want to see. We're tracing on port 23 because we're tracing on Telnet traffic. So let's clear this trace and refresh. So now all we're going to see is 23 in the trace. So open up a new Putty Session. There we go, we see it trying. Let's refresh. So here we see, again, remote to local, Ethernet 0, source is the laptop, destination is the same, destination and address, port 23. Here is the outbound packet on PPP1, but this time no ICMP. So all we see is another outbound SYN packet. So this is, in fact, sorry, this is the inbound to the router, and then this is the outbound from the router on PPP1. So we're not seeing any ICMP error messages this time. So that's why I probably recommend that you start off by filtering out traffic rather than filtering in. If there are any ICMP error messages, you are going to see them. So let's just clear that off again. But this time, let's filter in 8023. And I'll just quickly show you what a three-way handshake looks like. So let's apply that, refresh. So nothing there, that's good. This time we're going to go for 8023. And we get the login. So, back here. So the first packet, remote to local, Ethernet 0. We know what this is now. It's an inbound packet to the router, source of the laptop, destination of the ADSL interface. This time the destination port is 8023. Question marks are there because that doesn't relate to a well-known protocol. If that was 23, it would say Telnet. So here we see the SYN packet. Then if we scroll down, we'll see remote. So this one's local to remote, which on PPP1. Again, NAT is applied to the packet. So this is the new source address where NAT is applied. Destination port remains the same. SYN packet there. So the next packet down, again IP inbound. This one's from remote to local on PPP1. So this is the packet coming back from the ADSL router to the cellular interface. The source address is that of the DSL. There's the destination. And look what we've got. This time we've got a SYN ACK. So this is the second part of the three-way handshake. Come down a bit further. That packet has the NAT reversed. The source remains the same, but the destination is now the Windows laptop. And we can see just below there, we've got the SYN ACK. The next packet down, guess what? Remote to local, Ethernet 0. We've got source is the laptop, destination the DSL router, 8023. I'm sure we're all getting the hang of this now. And here we see the ACK. And then PPP1, we can see this is the packet going out from the router. So there's the NATed source address, there's the destination, 8023, and that's the ACK. So that's the connection setup. That's the three-way handshake. Job done. So that's a demo of a good working connection. Then the data you see after here, because this is Telnet, it's all in clear text, and as we see on the screen, if it's still there, yep. So we can see remote connection username. Here we see remote connection username. There we go. Right then, so hopefully you've got some good information on that. You can take that away and apply that to your own troubleshooting. No doubt the rundown in TCP will help you regardless, whether it's something you're doing on transport routers or not. But it's always nice to see how we can help by putting a transport router in there and help with your tracing if that's what you need to do. I hope you found this useful. Thank you for watching.